And so as we think about, where and how do we leverage AI, AI to us is how do we enhance the human experience, not how do we replace the human experience. And so we think that AI allows our humans to become superhumans, not as okay, we can have less humans now because we're using AI. And so, same with automation. When we invested in automation and digitizing, the vast knowledge that we had from attack cases, it was to allow those engineers to focus on higher value things. That time that got freed up, we didn't get rid of engineers, we just refocused them on, building that new knowledge on how do we provide better service to our customers. How do we, what we call look left and look right, so we're not just solving the problem that they originally opened the case on, but we're solving the other adjacent problems that we're aware of in their network that the automation has allowed us to do. And with the newer AI, what we call the generative AI models, Cisco has what we call a responsible AI framework. So everything that we do is founded around this responsible AI framework. And so we post it online. We tell you the different aspects of the responsible AI framework, but it's around transparency, privacy, security. And we have an organization that any group at Cisco that wants to leverage generative AI has to go through a responsible AI assessment where we look at the models that are being used, the training data that's used with those models, trying to determine is there any bias in the data, what guardrails are put around the models, how are we being able to detect any types of abuse of the models. And then besides the models, we have the use cases. How are they being implemented? How are we monitoring that implementation? How are we measuring drift of models and stuff like that? So I sit on the Responsible AI Committee at Cisco, and I can tell you there's a lot of ideas that are coming in for how people want to use and leverage these models. And it's tough to keep up, but at the same time, we have to kind of slow down a little bit to make sure that we're doing things in a responsible way, because that's critically important to us. And so let me start by talking a little bit about our predictive models that we've used in the past. And so I'm going to introduce you to our virtual attack engineer, or attack virtual engineer. And so it's powered by AI. We like to call them affectionately a humanoid. And you can see here on the right-hand side of the screen that just an example case that a customer opens a case. A few minutes later, our virtual attack engineer accepts that case. It reads the problem description, and it replies back to that customer over email with either a next step or potentially a solution. In this case, it's a solution to their problem. The customer goes and executes that solution, and it fixes the problem. They tell us, thank you, okay to close the case. The virtual engineer acknowledges that the issue was resolved and that they're going to go ahead and close out the case. And then we set a 24-hour hold timer because we want to make sure that if there's any follow-ups from the customer or anything else that those get intercepted before we actually close out the case. But all of this is 100% automated. And we do it not just on the simple cases like this one where it looks like it's a key ring, so probably a UCS device. We have a campaign where the UCS devices, after a year, they have self-signed certs on it, and the certificate expires, and therefore you get a key ring message, and customers have to regenerate that certificate in order for them to not get the cert errors when they're browsing. And it's a slam dunk open close case. But we also do it for harder cases. So for example, they have a Cisco firewall, an ASA or an FTD, and it crashes. That comes in, the virtual engineer will see that case and says, I know this case, I know how to solve that problem. It accepts the case out of the queue. It works with a customer to say, I see that you potentially have a crash. Can you please send me the output of either a show crash, to show tech support, whatever. It gets that in. It then decodes it. It looks for a matching bug in the bug database. If it finds a bug, it looks where it's fixed. It identifies what version the customer is running. It identifies where the fixes are. Then it notifies the customer the next version in their training that contains the fix and provides them a link to download the software. It then monitors and asks them what other assistance they need if they have any problems downloading the software. Once they've upgraded it, then it acknowledges that and so again, we can do some easy stuff like just troubleshooting, or we can do some harder stuff which would require some automated actions on the back end. So it spans the scope, and that's just what we call one mode of operation, which is the reactive mode, meaning a customer experienced an issue. They've opened a case and they said, hey Cisco, I need help. We also have two other modes of operation for our virtual engineer. The second is proactive. So we're monitoring customer networks. So customers have UCS or Nexus devices that are connected back to Cisco via Intersight. And if they've opted in, then we can kind of see the alerts and the faults that are in their network. If we detect a fault, say a DIMM failure in their UCS drive, as soon as that fault gets raised, we detect it. Our humanoid engineer looks at that fault and says, okay, I'm going to do some diagnosis, because not all faults that say it's a DIMM failure are actually hardware failures. It could be a transient software issue or blip or something. So it'll detect that, it'll run some tests, it'll go and look and make sure that there's no software bugs that affect it or any field notices that we have. Once it does that, if it determines that it's a real fault that needs an RMA, it'll then open a case, it'll generate an RMA, and then it reaches out to the customer, letting them know we detected a fault. Here's an RMA that we've already created. All you need to do is click the link and verify the shipping address. And once they do that, the part gets dispatched. It gets shipped to the customer. Customer verifies it. We actually monitor that the customer installs a replacement part, that the fault gets cleared, and then 24 hours after that, we would close the case out. And so, again, fully automated using what I'll call traditional ML models, right, or legacy. And finally, we have the assisted approach, where here, our virtual engineer is monitoring all of our tech engineers' backlogs. And so all the cases that are in everyone's backlog, it's monitoring them constantly and looking at it to say, can I add value to this case? Some examples of value that it can add. Say you're a tech engineer and you reached out to a customer and you asked for some debug information, and the customer hasn't responded in 2 days. The virtual engineer will see that. It'll re-respond to the customer, including the information that you asked for, basically just poking in, hey, your engineer asked for this information. So it removes work from our engineers doing what I call the busy work, because now they don't need to do these follow-ups with customers because our automation is doing those follow-ups. It can monitor if an engineer goes out of office, either on PTO or unexpectedly due to whatever reasons. It'll then look, and if the case is in customer pending, we're waiting on something, then that engineer will just monitor the backlog. If the customer replies, it'll let them know that the engineer is out of office. Can they wait? And if not, then it'll escalate it to another human engineer to handle that case. It can do things like if the customer is waiting on a bug fix via software, and it can monitor for that software posting on Cisco.com and Software Center. And as soon as it's posted, it'll notify the customer and the engineer that the software where they've been waiting for has been posted, and it'll let them know that they can download it and resolve their issues. So those are just a sampling of the assistive mode of operation of our virtual engineer. And so it's technology agnostic, and it's 100% API driven. And we've helped over 500,000, probably closer to 700,000 now, but the last time I ran the numbers back in January, it was over 500,000 customers that our virtual engineer has helped with. When the virtual engineer owns the cases, they're 36% faster resolutions, and they've got a 5-point higher customer satisfaction than our already industry-leading satisfaction on our normal tech cases. So that's pretty impressive. It is award-winning, so we've won multiple awards in the industry that we've submitted to, and we also have multiple patents, both patents issued and pending. So now let's get into the fun stuff. But before I do that, let me pause and see if you guys have any questions on what I presented so far.
How long have you been running that?
How long have we been running it? Technically, we launched in December of 2019. And I say technically because at that point, it was like an airplane that was going down the runway with one engine, one wing, and no tail. And I kid you not, that's exactly how it was, because it was an idea that I had that I got 2 people together, and we just started saying, hey, how do we handle, honestly, how it started was occasionally in support, as you all know, you'll get spikes of high volumes of cases. Some incident happens. Unbeknownst to you, you guys can't predict it, you just don't know, and all of a sudden we get a flood of cases. And we're not staffed for that. We're staffed for that. All of our engineers are pretty much occupied all the time. But when you get a rush of thousands of cases that you can't handle, you guys get overloaded. At least we do. Assuming, can I get nods that you guys have the same problem, or is it just our problem? Okay. So so we said, well, how do we handle it? A lot of times these spikes are known issues that we have known solutions for, and so why can't we automate that? So we started with that premise, and so we started just in our spare time, kind of working on building out some things, and we honestly started with kind of a harder problem, but the ASA crashes is where we actually started. And we said, we built this system to decode crashes and match them into bugs. So we were like, hey, we can kind of hook all these pieces together and have this automated system. Well, in December, we had an issue where there was a vulnerability in our ASAs that if you exploited it would cause the device to crash. That got published. Customers did an upgrade. Then a researcher, just unrelated, just decided to start scanning the internet for research work with this vulnerability and started crashing all these devices. And we had all these pieces in place. We just, there was just no reason to do anything. So we turned it on, and we didn't really have the models fully trained, so the models that are doing all the responses back to the customer. So we had a lot of pieces in place, but it was like I said, an airplane going down the runway. We had thousands of cases. The AI was responding faster than we could overwatch it to make sure it's doing all the right things, because one of the tenets I had is that it can never be wrong. And so if it can't be wrong, then how do you make sure that you're inserted into the process to know that it's giving the right answer before it actually gives an answer? So we have this process and this view that we could see everything that customers are asking, everything the models are responding to, and then ability to approve those things before it happens. And some things will approve, and some will be actions that we don't need to approve. Like if we're knowing that we're matching a known bug, we've got high probability of it, we don't need to approve that. But if a customer is asking some unrelated question about, hey, how do I do the software upgrade? We need to make sure that the models are responding appropriately. And so we have these abilities for humans to oversee that, for them to change the answer, which retrains the models before that actually gets sent out. And we put timers in there so that if things are all good and we don't have to have a explicit approval or change, that the model will actually send the response to the customer. So anyways, it was chaotic in the beginning, but it took probably about 1.5 years or 2 years before everything got in place. So it's really been the last couple of years where this has been just humming along. We've just been expanding the knowledge base and the different problems that the virtual engineer can solve.
It's like someone raised their hand up.
Someone raised their hand. Who was that?
Richard.
Yeah. Hi.
Hi.
Hi. I joined a few minutes late, so I'm not sure if this has been discussed already. But what you're saying sounds very, very exciting. We are also trying to do AI in software AG. I'm wondering if there were some use cases which you found to be more, suited for AI. And I asked this because we are finding that the simpler cases where the interaction between customer and the agent is limited to 1 or 2 iterations is, of course, we find better success there. But where our cases go into more complex situations and the incident runs, let's say 3 weeks, and there are, let's say, 35, 50 interactions before we reach a solution, are finding it a bit harder to figure out how AI can help. I'm wondering if you had some experience in the complexity or solving complex cases using AI.
Yeah, so obviously you'll have a larger benefit on the cases that don't require as much interaction, right? Because typically if they require a ton of interaction, it's generally because there's an unknown solution, meaning the problem that it's defined as a case was opened isn't clear what that solution is going to be. And so say it's a net new software bug. Well, when that case comes in, you don't really know all the things that you're going to need to gather because you don't know what the actual resolution is until you actually work through that case and identify it's an unknown, net new software issue. So yeah, well, I mean, we focus on, as the case comes in, do we know what the problem is and do we know what the solution is? And if that's true, then what we call create a campaign, which is problem, all the different steps you need to take to get to that solution, and we train the models on those solutions and add in any type of automation. So if it's like a licensing issue, and you need to generate a license and deposit it in a smart account, right? That's automation that you do on the back end, but you have to identify, okay, well, who's the user, right? What's the device? What are they entitled to? What do they already have in the smart account? And all that stuff you have to kind of automate, and there's some interactions that you have to do as well because you have to ask the end user for that, make sure you get that data before doing it. But yeah, absolutely. If it's the more complex and the more interactions you have, the less return that you're going to get if you automate it. Mm-hmm.
I'm curious if you experienced any data challenges as part of your development and how you've worked through those.
Yeah, I like it. Data and access. I'll expand it to both, right? Because I like to tell people I probably lost 4 years of my life just trying to get a human account for a non-human at Cisco. Like that was the hardest thing I've ever done in 24 years at Cisco. Because, you start out thinking, hey, it's simple. I've got this thing I created, it's a humanoid, and we want it to do everything a tech engineer can do. Okay, great. But we have all these systems that are built that you create the human account, you need an address, right? You need a phone number, you need an email, which we need an email. But that person's supposed to get paychecks, right? They're supposed to get bonuses. They're supposed to do, and so all of our systems at Cisco weren't designed for this humanoid. We had generic accounts, which are machine accounts, but with machine accounts, you can't get all the permissions that a human has, which is what we needed because we're effectively duplicating a human. And so that was challenging. Related to it is API access. This is all API driven, and it's great if all your tools are API first, but nobody is like that, right? And so you've got a lot of legacy systems, and so as we integrate with, I mentioned licensing. Well, we had to go integrate with a licensing system. If it's crashes, software posting, we have to integrate with those systems. And so you're limited by those systems that you integrate with, and often they're not, either the data isn't the best quality or you don't have access to that data. So we had to design around that, to be quite honest with you. You can't wait for those systems to upgrade or you'll be years in the making it. So we just designed around it.
Yeah, for the cases where no human intervention, you send surveys of those? I was just curious if you're
we do.
NPS. I assume they rank pretty well, right?
Yeah, so as I said, they're about 5 points higher than a human-owned case. But yes, we send surveys with every TAC case.
Hey, David, on the virtual engineer, how much autonomy does this virtual engineer have? You were explaining like it'll look at an engineer's backlog and it'll reach out to a customer. How much freedom does this virtual engineer have?
I mean, it's not a sentient being, right? So we've coded it, what it can and can't do. So when we said, hey, we want you to do what we call follow-ups, we tell it, some work groups are set at 3 days, some at 5 days, some at 1 day. It just depends on the types of cases and what they're designed for. But when those times occur, right, it'll review all the backlogs of the engineers in that work group, and then it'll look at the cases and read them and find out which ones it can respond to, and it goes in a response. But it doesn't, it's not like, just some generative AI model that has absolute freedom, right? It's specifically coded to say, hey, these are the things that you're supposed to do right now. Yeah.
So 2 questions. One, do the end customers know that they're talking to a virtual assistant?
Yeah.
And do they have an escape route if they don't want to go down that?
Absolutely. So really great question. And I struggled with this in the very beginning, back in 2020. And my intent was it's very clear if you hear me speak, I've never used the word bot once, right? And while most people think of this as a bot, it's really not. And we didn't want customers to think of it as a bot. So all exchange is done via email. So most of our TAP cases are via email, otherwise it comes in on the phone. But the vast majority are via email. So that's how it interfaces. Its signature, it says it's a virtual engineer, but customers don't really see that. The name of it, we called it Sherlock Holmes to try to give them a clue. In the beginning, very few customers noticed, and it was intentional that we didn't want to be, hey, we don't want to hide it from you, but at the same time, we didn't want them to have to think about, how do I change how I'm going to speak to this thing because it's not a human. That was very critical for me, is that we're here to solve a problem. We're not here that you have to learn how to get your problem solved, but it should be transparent to you. You ask a question, we'll give you an answer, right? But at the same time, I don't want to hide it from you. And so it's kind of like this really blended, tightrope that I was trying to walk, that I don't ever want to hide it from a customer that's a virtual engineer, but at the same time, if I explicitly say, hey, we're a virtual engineer, and the first question is like, hey, what is this, right? What do I have to do? How do I talk to it differently? And we don't want to put that burden on the customer. At the same time, if they ask them, hey, are you real or not? It gives back a funny reply. No, my creators named me this, it gives back this great funny reply. Occasionally, in the very beginning, we had, one customer was like, wait, you're not a human. I know that. I want to talk to a human, right? And that's fine. They can ask that, and it immediately just escalates it to a human. So we just requeue the case to a human engineer. But yeah, anytime that it doesn't know the answer or it needs help, it can either raise an alert to a human, what we call an overwatcher, that sees that and it can respond on behalf of the virtual engineer, or it'll just escalate the case to a human.
You mentioned that when you were building the TAC virtual engineer that you settled on a specific use case to try to troubleshoot or to try to solution. Can you talk about the reasons why or what factors played into you selecting that specific use case as kind of like your starting block?
Yeah, I mean, we look at the volume of cases and we try to figure out where can we have the biggest impact. Right? And then beyond that, it's, as I said, how do we determine a problem from a problem description? You know, when customers open cases, a lot of times they don't give you a lot of information. But that's critical because that's our decision point of, are we going to take that case for the virtual engineer or is a human going to take it? And so we needed a way, you know, we had to look at all the cases and say, where can we kind of identify enough problems that the virtual engineer can kind of solve and have a return on that investment, and that we can identify in the beginning, and that we can, you know, solve it in the end. We know the entire end-to-end solution. So that's still what we look at today when what we call add new campaigns. And a new campaign is a problem-solution pairing, and then we have the ML models that we're training specific just to that campaign. And so if you open a case on a crash, you're never going to get a response that's related to software or a software license or something like that, because the models just don't know anything about it. They're only trained on that problem solution pairing. And that wasn't critically important for us because I said, you know, we want to be 100% accurate. We never want to be inaccurate. However, if we are inaccurate, I want it to be on the same plane. You know, I want it to be related to the issue and not something, you know, way off. So a lot of bots today, they're trained on all types of information. And because of that, you might ask it a question and get some random answer. I never wanted that to happen, right? And so all of our models are trained specific to that campaign. So every campaign, we've got multiple models trained just on that one technical problem solution. Yeah.
So is this humanoid, the virtual agent, are they restricted on the priority of the cases?
So yes, the question was, are they restricted on the priority of cases? So at Cisco, priority 1 and priority 2 cases are generally on the phone live, and so it won't take those because it's not speaking, although in the future that might change, but right now we don't have it speaking to customers on the phone, and so yeah, it won't take P1, P2 cases.
And what happens if the case is reprioritized by the customer?
We'll detect that instantly that the priority was changed, and we escalate the case to you. Okay. Yeah. So we have a lot of times that, you know, we'll monitor things, and if it's not right, you know, our intent isn't to harm the customer in any way. It's always to help the customer. So if there's something that the humanoid can't do, it instantly knows that and it escalates the case. We don't want to keep it with it longer than it should.
How often are your models trained?
How often are our models trained? So we have different models. Some are trained, you know, could be, it's not a time thing, it's an instance thing. So for example, if it suggests a response and the response is wrong and a human sees that the response is wrong, it'll change that response and it instantly gets retrained as soon as it sends out the response that is different, right? So we detect that, hey, here was the predicted response, here was the change in response, we're going to train the model on that. So we can do it, you know, multiple, you know, hundreds of times a day, but realistically it's, you know, could be several times a day, but it varies depending on how long that campaign's been running. So in the beginning, the models are trained a lot when you start a campaign, but you know, you get all the different variances of questions that a customer asks around a given problem, and that kind of levels out. So then the training of the model, it just happens less because there's less variance and less differences.
It sounds like you're dealing with hallucinations by trying to have a bunch of different models.
I wouldn't say hallucinations, right? Because hallucinations are related more towards general models, which I'm getting ready to transition to, right? But these models are the traditional ML models where it already has a preset of text output in response to it, right? You're just kind of matching the best.
So how broad are your campaigns? You talked about a model for a campaign. What's the scope of a campaign? Is it
It's a problem
specific
and
problem?
solution. Yeah,
Real
specific problem.
Okay.
Yeah, a singular specific problem. So for example, the one I showed earlier was a UCS keyring, the certificate expired on a UCS device. Now, we have the same thing with, say, an ICE product where this self-signed cert expires. That would be a different campaign. We can reuse a lot of the training for it, but how you fix it's going to be slightly different. But we know what the customers are going to ask because we've already done the UCS ones. We know, you know, all the different variants and types of questions they ask, so we do it. Because it's never just, hey, here's the steps to do to resolve it. That's the easy part. It's they ask 1,000 different variations that are somewhat related, right, but not always, and you can't predict that stuff when you're creating the campaign at the beginning. So that's what you have to watch for. And so we say it generally takes about 50 cases of the same problem for the models to be trained well enough that you can kind of be hands-off. But the first 50 is really about, you know, understanding what variants of questions that the customers are asking around it. You know, with a keyring one, I'll give you an example. The variance of a question is, am I going to have downtime? right? Well, it's not really related to your problem, but it is related. But it's like, okay, well, you can predict how long's the downtime, right? And if there's no downtime, they're still going to ask, well, how long's the downtime? And so it's all those types of questions that you have to kind of design and train the models for. Yeah.
Oh, you had mentioned tenants earlier that you used to design the AI model. Are you going to cover those tenants by any chance?
No, not really. I was just
I'd love to hear
only
about
because the
that.
first one is, it can never be wrong. Clearly, you can't achieve that of never being wrong. But the reality is, I want it to be less wrong than a human. But the tenet is, it can never be wrong, because if we as a team, and we have a very small team, if that's our tenet, then how we design the architecture, we design it in such a way that how do we detect if the model is going to be wrong, right? And how do we make sure that when the model's wrong, that doesn't get sent to a customer? So that's a key tenet of mine. But in reality, I'm happy as long as we're less wrong than a human is. And humans aren't perfect. I hate to tell it to you, but I look at tech cases every day, and they're not perfect 100% of the time, right? So if we make a mistake and give a wrong answer, like I said, as long as on the playing field, which is another one of my tenets, I'm okay with it, right? We can say, I'm sorry, customer, we didn't give you the perfect answer. And customers are fine.
Yeah, have you considered taking your virtual engineer and putting it more towards your portal type access? And if you have, kind of what decisions came into play?
We have. So, have we thought about exposing it? So yes, we have. We do expose a little bit. We've got the Cisco Support Assistant now that we're kind of integrating some of the capabilities into, and that's more of a chatbot experience, which is available on various, we call them portals, right? But on Cisco.com, through our Case Open portal, and we're integrated in some of our BU products right now. And so that's one way we're doing it. The other stuff, I'll just say, there's some politics involved to try to do it. But yeah, we thought about it. Our focus is, having the best experience for our customers and trying to meet them wherever we can.
Sorry, one more question. I know you want to move on, but
I do, because you guys are going to be excited about the next part.
Yeah.
I don't want to run out of time.
I'm just kind of curious about the employee satisfaction, the employee engagement, right? Just from, so if we flip it, customers seem to like it, but what about the employees?
They like it. You always have, I won't say that it's 100% of employees like it in the beginning, right? Especially when we would go and monitor their backlogs and go respond to them, and they'd get upset. And hey, I own that backlog. I own that relationship with the customer. Okay, but you haven't talked to them in 5 days, right? If you want to own that, if you respond in less than 5 days, the virtual engineer is not going to do it, right? And so that's like, you have to have that balance. And so it's kind of like this convincing that, hey, it's there as a backup, it can operate in a backup mode, or we can turn the timers down and it can be the primary thing so that it's always doing the follow-ups and you never have to, and you get that time back. But you have a continuum of people from the adoption and the change, I would say. But by and large, yeah, I mean, it's I think that means to move on.
David,
Next slide. All right, so let's start talking about generative AI.
David, there's one question on WebEx, and is it only providing answers, or is it capable of connecting to a terminal and troubleshooting?
So it does not do live troubleshooting on a customer's network. But it's answer for that.
Is that no or yes?
Yes. Yes. I like where you're going. So let's talk about generative AI. And so, as a life cycle of a case, we look at all different parts of the case and say, where can we add value? Generative AI really unlocks some net new capabilities that, our traditional models didn't provide for. And let me just talk now about what we call our Cisco AI Assistant for Tech. It's a lot of words there. So what are we doing with generative AI? I'm going to show you in just a second, but I just wanted to run through kind of the majority of things we're doing, because I'm only going to show you some of those. But we assist support engineers in initial responses to a customer as well as follow-up. So basically, anything a customer has in a case, we can assist them with responding to that with generative AI. We can troubleshoot net new issues. So with our virtual tech engineer, we had to know what the solution to the problem was by the time that case was open. Now with the generative models, we can use those. We don't have to know what the solution is. So we can take any case and start working it and make progress on it, right? We can take actions on cases in cooperation with traditional models. We can generate current status updates as well as action plans. We generate resolution summaries, we create RCA documents, and we can also measure the customer sentiment, all with generative models. So let's look at an example of how this actually works. So here we have a case open on the far left. And as soon as that case gets open, we look at what's the problem, we look at the product, we look at the type of issue that they're having, and we route it based on a whole bunch of rules, right? As soon as this routing happens, it goes to a queue for an engineer to accept the case. In parallel, it goes up to our generative models, which see that we take in the title, we take in the problem description, we take in a lot of the metadata that we have about that case, we send it to the generative model along with some prompt engineering that we do, and then we spit the response back out into the case. So when that engineer accepts that case, they see the customer's problem description, and then they see what the generative model suggests as the response to that. And the engineer can choose to use any of it, they can choose to use none of it, or they can choose to use some of it. Okay? And then this happens again once the engineer responds and the customer replies back. We do the same exact thing over again. So, well, as soon as that reply comes back in, we send it to the generative models, we do the prompt engineering, we read through the case and anything that's happened on it, we pass that to the models, we push that back down into the case. So the TAC engineer, when they look at that case, they see the customer's response and they see the generative response, and they can choose to use it, some, or none of it. Okay? Yeah.
Quick question. I think this is great. One of the things that I've heard from different organizations is this concern, especially when they have, like, let's just say a level 1 group.
Yep.
The concern that they're just going to take what generative AI dumps in a case and then parrot that out to a customer.
Absolutely.
Have you seen that? Is that a concern? Like, how have you managed that?
We've seen it as a concern. We haven't been able to validate that it's a valid concern.
Okay.
And what we've done actually is where it's been a concern, we didn't enable it for those level 1 so with level 1, we also have a level 2 behind it. It's enabled on the level 2, and they'll evaluate. And as they evaluate, and I'll show you in a second how we kind of monitor and evaluate the responses. As they evaluate that, when they're comfortable with, hey, this thing's really good, then we choose to enable it on level 1. Okay? So we basically just don't enable it on level 1. We only do it on level 2 where that becomes a concern. Okay, but let me move forward because I want to get through some things that I think you guys will find interesting before we go. So what does this look like for our attack engineer? So I wish this screen looked a little bit better. But at the very bottom is, this is the customer sentiment. They open the case, they have this problem description around configuring the ISP connection on a 5585. He's not able to route the traffic. So the ISP router seems to time out. That was the problem description from the customer. So here's the generative response that's injected into the user interface that the TAC engineer has, that case. And so there's this edit and send button that if they click on, so when they hit edit and send, we get a dialog box. All this text that was generative response is now editable. So the TAC engineer is able to edit that response. And then when they're done with it, they can go ahead and hit send. But prior to that, you'll notice that we have an intention to let the TAC engineers know, hey, this was a generative AI response. You own any text that you send to this customer. You're responsible for it. And so it's just a in their face type reminder that, hey, this was generated. You need to review it. You need to approve it because when it goes out, it's going out with your name. It's not going out with the virtual engineers. You own that response. So also, we have built-in feedback. So right here, when the engineer is looking at this generative response, they can give us feedback to let us know, hey, how well did that response do compared to what the customer asked? And there's a text box with it, so you can either just do thumbs up, thumbs down, or you can provide feedback. If you provide negative feedback, then that opens an automatic issue for us in Git that we go and look at, and we look to say, okay, well, what can we do to improve the model? What can we do to improve prompting? What can we do to make modifications before we close out the issue?
What base models are you training off of?
We have several different models that we've used. Depends on what action we're taking and what we're doing. But some of the best performing models, obviously, out there, like OpenAI GPT-4, is probably the best for net new unknown issues, right? But then we also augment it with search capabilities, function calling, RAG, and prompt engineering as well. Right? So we're just not using just base model off the shelf. Some of the things that we want to monitor, right, is usage. So here we can monitor how much is it being used by different work groups, different technologies. Are we getting adoption? Because just because you infuse something into the workflow doesn't mean that someone's going to actually use it. Additionally, when it is used, how accurate is that model? And so again, we look at this from most importantly from a technology basis, because that helps us understand how good a model is in a given technology area, because you don't really want to measure it based on a work group or a geography or anything like that, because this is really the technical response. How good is it? And where you can see here like 92.35%. That means of the text that was generated, 92.35% of that text was retained. So the human engineer modified 7% of that before sending it down, right? And you can see on some of them, so this top row is the responses to actually the problems. This bottom row is the action plan. I just picked two random things to kind of give you an example. So action plans is more where the model's reading through the case and trying to understand what's the next action that needs to take and who owns that action. So on things where you're doing more summarization or analysis of already completed data, the retention is much higher than on net new problem issues where the model's having to hallucinate, if you will, right? Because all models do is hallucinate, right? It's just the accuracy of that hallucination. On the token prediction, that's where we're trying to measure the accuracy. And where we see it dip down, we look into that and try to understand, well, what's the issue? And so, for example, one of the models we were using, wasn't very good in optical, and so we added a whole lot of RAG and a whole lot of additional function calling and other stuff. And the model usage in the beginning went from about 45% of text retained to now it's above 90%, right? And so my goal is, in the 80-85%, I think is pretty phenomenal for where we are with the technology. But when you're showing the 90%, I think that's really great.
David, there's a question. Is it multi-language support capable?
Yes, it is. I will just to show you all. I have a. So here's I didn't show them in the backup, but I'm gonna hide these real quick because you asked. So like on our RCA docs, at the end of the case, we can generate a root cause analysis. And here's an example of one. Well, the customer another customer was in Japanese, and so the model generated in Japanese. We didn't have to do anything different. The model detects the language that's being used, and it responds back in the same language. And that's actually from a real case. So let me get down to some feedback. And so I just went in, I mentioned the thumbs up, thumbs down, and you can provide textual base. So I went in there and just grabbed a screenshot of some of those responses, and I'm pasting them here. So these are what our actual engineers are saying about this capability, right? Verbatim from them with spelling mistakes and all. And so they largely love it. You always have people, on extreme ends, right? Some that absolutely think is the greatest things in sliced bread, and you always have one or two outliers. It's like, wait, the world's coming to an end. Something's gonna crash. But by and large, the vast majority really enjoy it because it's helping them. A lot of times they find that it's better than the language that's being used, the diction, the formulation of the words is better than they speak. And it's actually good for non-native English speakers because it actually improves, the text that they're sending out. And so we find that really interesting.
Question. In the previous slide, you had a 36% decrease in time to close the case.
Yeah.
Is that just because you're achieving that because it's only responding to things that it knows that there's a known solution for? Like those are going to be closed quickly anyways, right?
Not necessarily, right? So the question was previously with our virtual TAC engineer, which was using, on that portion of the presentation, that data was focused on using the legacy models, not the generative ones, even though now it's using generative. But on that 32% reduction, it's often the speed at which it can respond, right? So we know that CX or satisfaction is closely correlated with how quickly the cases respond, right? And one of the top customer pain points is timeliness of communication. Well, with a virtual engineer, it's instantaneous, right? It's seconds. It's not hours. It can be seconds. And so the 36% faster to respond, yes, it can do that on very complicated cases that can go a long time, or it can be on very short open and closed cases. But even with that 36% faster, that's with a built-in 24-hour wait. hold timer too, right? Because we're closing cases after 24 hours. And in the majority of them, because we want to make sure that, you know, we were closing them instantly, and we found out that sometimes customers said, hey, close the case, but then they had a follow-up question. And if the case was closed, the virtual engineer wouldn't see that follow-up. And so we now have this hold timer just to make sure that everything's good.
Is there some type of pipe, like can't respond to multiple at the same time, or is it a queue, or how is it responding? Like, what if there's 500 cases that it can respond to? Does it do them sequentially, or can it respond to all 500?
It's in parallel. So, I mean, right now, if I go and look at its backlog, there's probably 5,000 cases in its backlog that's managing, that it's owning right now, right? And it's just constantly doing, that's not to mention the engineer's backlog that it's doing the assistive type stuff on. That's just the cases that it owns, right? I'll give you an example. Last week, what was it, Tuesday? Maybe it was 2 weeks ago. We had the arcane door piecer, right? We had 4,000 cases over a period of about 3 days, and the virtual engineer handled about 3,500 of those cases over those 3 days, right? So I mean, it's chugging through. So second to last slide.
You mentioned chatbot earlier.
We're not a chatbot.
Is your well? My thing is like, is this stuff you just showed up in Gen AI? Is that the foundation you're going to try to drive through chatbot, or like validate internal first and then go external?
Yeah, exactly. Yeah, you got it. So we're on this journey. This is my second to last slide, and I wanted to make sure that I kind of end on time and give you guys time for questions too. But you know, we started out with automating a lot of our capabilities. So our human knowledge, how do we digitize it? How do we put in our detections? How do we get to automation? I then walk you through the story of how do we then leverage AI, traditional predictive AI, to solve cases. And now we're using generative AI to both solve cases and to assist humans. But we really want to get towards this, you know, self-remediation. So you think about all these things that we're doing with generative AI. Well, I couple that with connectivity to devices, with the ability to log in. I think you asked a question about, can it log in and make command changes? Well, technically it could today if we enabled it, but we haven't yet, right? But we want to get there, right? We want to get to the point that we're detecting the problems, we're able to solve it, and all we're doing is notifying the customers that here's a problem detected, here's what I did to solve it, you're good to go. So, in closing, if you're not on this journey of leveraging AI and specifically generative AI, you're already behind, right? I mean, if you get nothing else from this message, that's what I want you to get. You guys need to be investing in it. You need to be experimenting. You need to be deploying it eventually into production. Just start now on your journey. And I say engage early adopters and build a community. You'll always find you've got engineers, they love technology, they love the latest technology. Get them together, right? Build a community. I've built several communities at Cisco here around AI and generative AI, and it's exploded. It started out with 12 people. We now have over 4,000 people across the company that are in this community. And one of the communities, we've got a bunch now, but you know, engineers, they want to learn, they want to play, and they want to do something that provides value. Take that technology, provide value. Use generative AI to assist your engineers, not to replace them. Integrate into workflows, and then measure, collect feedback, and iterate. Okay, so that's my closing thoughts. But this technology is advancing so rapidly, you have got to keep up with the pace. You know, OpenAI yesterday announced the multimodal models, right, where you can take and you can talk to a model and it can translate in real time. You can talk to it, it can generate videos or images. You could use it to capture a video in real time, and it'll explain to you the scenes around you. So if you're blind, right, they have a video of a blind person walking. So what am I looking at? Oh, you're looking at ducks swimming in a pond. You're looking at the Tower Bridge in London, right? And it can explain the scenery around you, multimodal models. So going back to, well, can we have models that can talk to a customer over the phone? Absolutely. And that same model cannot just respond, but it can take actions textually. It can read diagrams and images and respond back to the customer around them. So keep abreast of where the industry is going and make sure that you're getting people to do it. And I say all this, I also want to emphasize the fact that you don't need a lot of people to do these things. So let me just interactive portion. How many people do you think I had on my team that built our virtual engineer? If it's 100 plus people, raise your hand. Nobody? Okay, good. 50 plus, raise your hand.
You've already told us it doesn't take a lot of
You got a virtual engineer, so I'm going to let your number go down. So
okay.
The other one, I'd probably say
25? 1, all right. 15, 10, 8. All right, it was 6. It was 6, and that wasn't their full-time job, right? I was one of the 6. It wasn't our full-time job. We were doing this along with probably 5 other projects and jobs and things that were related, and our part-time, we did it. You don't need a lot of people. For the generative AI that I just talked about, where I showed you the screenshots and all that stuff, 2 people and me, right? And it's deployed for the entire company base. You don't need a lot of people. When you get a lot of people, it slows you down. You get more than 6, 7, 8 people, you now have to have consensus. You've got to go through project manager. You got to go through all this stuff. And when I say the 6 on the virtual engineer and the 2 now, we're not just coding it. We're not just developing it. We're not just putting the product. We're doing trainings. We're doing the monitoring. We're doing the feedbacks. We're doing everything. The CXSAT surveys are, everything, end to end, right? So think small, execute quickly, and go and embrace the technology.
What's your compute cost like?
What's the compute cost? It's much cheaper than you would think. So I'm assuming you're asking on the generative AI, not the traditional AI, right? It's cheap. It's could be the hundreds to the thousands, and it just depends because it depends how many thousands of cases we're doing. And so it's hard to say like, hey, if I told you, hey, it was 10,000 last month, well, it gives you nothing if you don't understand how many cases and how much tokens it used, right? But we're consuming trillions of tokens, right? And the costs are cheap relative to what you're doing is really cheap. And it's going down, right? Yesterday, GPT-4o was released, right? It's a 4 times increase in speed over GPT-4 Turbo and a 50% reduction in cost, right? And GPT Turbo was a 4x reduction in cost from GPT-4, right? So you just think about that. And we're using different models. We use some that we've fine-tuned and used some open source models. We use GPT 3.5, 4.0, 4.0 Vision, right? I didn't tell you about that, but if a customer sends in a topology diagram, a vision model can analyze it and describe it, and then that description can go feed into the problem description, so it helps the other model to understand.
How are you addressing security, data security?
Yeah, so multi-stage, right? So everything from the foundational legal agreements to the model providers to validating the environment itself through our Cisco Secure Development Lifecycle process to validating, like I said, the responses by a human overwatch. We've got a whole plethora of things. We go through a whole responsible AI process, right, where we evaluate the models, we evaluate the use cases, we make sure that we've got guardrails in there. Yeah, it's a lengthy process.
I have a question. So you guys have clearly mastered a lot of this. Do you, maybe through TSANet and members of this community, do you share best practices, or is it all proprietary? You don't, put it out there, or is there an opportunity to create communities through TSANet for other companies to learn about what you're doing?
Yeah. Before, I would say, until recently, we haven't really put anything out there because all the partners that we talk to, not partners this way, but like the technology partners that were providing models and stuff like that, it was clear that we were kind of ahead of them, what they were doing and what they saw other customers or partners doing. And so we don't want to kind of share that. So we actually have, like I said, multiple patents pending on a lot of different things because I didn't talk about, we've got a whole bunch of like an agreement system where, you can use multiple models and how do you determine which one's the right response and how do they agree and all this other type of stuff that we've got. But we're starting to share it more because we want to get it out there. We want other people, as I said, the last slide, right? I want you guys to be on this journey. I want everybody to be on this journey. And we'll probably do more of it, but you got to go back to, remember, there's a team of 3, right? There's a team of 6, right? The same 3 that are on the 6. And so we do what we can, but I hope this talk helps. But yeah, we'll try to do more. Okay, thumbs up or thumbs down?
Thanks, man. That's great.